Some hybrid vehicles like this Chevy Volt behind me have an auxiliary electric coolant pump that circulates the coolant throughout both the engine and the battery packs in order to keep them cool. Now, when you refill that coolant system, a lot of times you have to do a bleed procedure in order to get all the air out of the system. So let's walk through it. Okay, so this test is under the hybrid powertrain control module number 2. And if we go in there, it's under functional tests and is a special function. And we see we have the hybrid EV battery pack coolant pump bleed procedure. Go in there. And it says refer to service information when using this test. Connect the required equipment. Connect the battery charger to the 12-volt battery. Vehicle must remain in service mode during this procedure. Now, the required equipment that it says, if you look inside the service information, these need to be vacuum filled, so you need to use a special vacuum fill coolant filler. So really just walking you through the procedure here, so we don't have any of that hooked up, but just make sure you check your service information for that. So I'll just hit continue to trigger the test. It says make sure the proper coolant level is in there, and then the procedure will run for about 30 minutes, and you can exit the procedure at any time if you wish to do so. So I'll hit continue. It's going to go in, it's going to start the tests, and you can see the numbers are starting to change there. If I open a couple graphs, you can see there it's the percent that it's commanding it on. So it started at 6%, it's all the way up to 50%. And it's cycling through on the pump. So you can see what's going on there. So once the procedure is complete, a final screen is going to come up to tell you that the process is complete. And once all that's done, you've bled all the air out of the system and the job is done. Hello everyone, welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that, type in your question. I'll get to those at the end. And if you're watching on YouTube, feel free to use the live chat function, and I'll get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 12, 13 years or so. Helping Texan shop owners get the most out of their diagnostic equipment touring around North America. Before that, it was a couple years as a diagnostic sales rep at Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru, so worked in a dealership and just over time became the default diag guy in the shop. So I was ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. It's been about 30 years under hood experience for me. Our topic tonight is hybrid and EV vehicle diagnosis and repair. So we're talking about there's a lot of similarities, right? A lot of them share parts and a lot of differences between them. And we'll just kind of talk through that and how we might go and diagnose some things with it using some scan tool functions and some other things we might need. So let's start off with electric vehicles, right? So these have been the hot topic as of the last, I don't know, probably 10 years or so, maybe a little less, but really picked up some steam over the last 5-10 years. And basically it is a rolling battery, if you want to think about it that way. A lot of times the battery itself is part and parcel of the chassis of the vehicle. So it's going to have a big old battery. Usually it takes up the whole underneath of the vehicle. It's going to need a battery heating system, an electric motor, and a lot more other components, which we're going to get into right now. So of course we talked about the battery and a battery cooling or heating system, because when battery is going to charge at its best in a certain temperature range. If it's too hot, then it will cool it off, and if it's too cold, it can warm it up. Sometimes depends on the manufacturer, but oftentimes it pulls double duty as cooling and heating. I need a voltage converter because we got high voltage coming out of the battery. We need to convert it to other voltages, miscellaneous voltages around the vehicle. Also has a regenerative braking system that helps charge the battery. I don't know if it does a ton when you're braking because it's such a small amount of time, but it does have some regenerative capabilities. And then, of course, the electric motor or motors, depending on how the vehicle's set up. Some of them, if they're just like front wheel drive, then it would probably have just one motor to share the two. Some all-wheel drive models will have three motors. They'll put one in the front, they'll put two in the back, one on each wheel. And then, of course, the charging systems. I'm going to plug this into the wall in order to charge the battery, usually overnight or when I'm, at work. Some places have EV chargers, that sort of thing. But I do need a system to be able to charge that big old battery. And of course, safety first, high voltage in here, 300, 400 volts. Positive and negative voltage cables connected to the high voltage battery pack are controlled by 12-volt normally open relays. When the vehicle is shut off, the relays stop electricity flow from leaving the high voltage battery pack. So we just need to know that everything's insulated from each other, but it is high voltage, so we need to be careful working around it. Basically, a good rule of thumb, if you see anything in orange, be super careful. So it's usually the orange wire looms and plugs and connectors and things of that nature. So the battery itself is multiple small low voltage batteries linked in series, which then gives us a high DC voltage. It can be 300, 400 volts plus, depending on the manufacturer and how they have it set up. Oftentimes it is nickel metal hydride or lithium ion. You hear about lithium ion a lot more nowadays. I think probably early on it was nickel metal hydride, and then they kind of changed over. And EVs have large packs. They're quite heavy. There's specialized equipment to work on these, specialized lift tables and things of that nature that you would need to use in order to get this battery out. Also, as a consequence of that, just the weight of the battery and everything that it's carrying around. Oftentimes, you hear stories of tires wearing out much more quickly than they normally would, just because of the extra weight of the vehicle puts extra load on the tires, extra friction on the tires. So then they tend to wear out a little faster. Battery heating and cooling system. So battery must be cooled to maximize performance in life. Like I said, it charges best at a certain temperature. Three methods are used. Passive, probably not so much in an EV, more of a hybrid. Active air cooling, where it uses fans, and then liquid cooling, which I think is probably the more popular design, is to actually cool the battery pack using a specialized coolant that is in there. So this is on a Audi, and you can see the different coolant passages that go over this massive battery pack there. Liquid cooling can also warm a battery if needed. Coolant must contain deionized water, because if we want to not conduct electricity, we want to have deionized water. The ions in the water make it easier to conduct electricity. Coolant is either warmed or chilled depending on the situation. So there's a heater there, or there's a heater there, and then there's a chiller there. So it just kind of depends on which way the valve goes as to whether or not it gets heated and cooled. And then it goes over all the different functions in the system. It's going to have an electric water pump, and it's going to have a radiator oftentimes, just like an internal combustion engine vehicle. So you can just run the coolant through the radiator to cool it off. The converter/inverter is going to convert AC to DC and back and forth. Converts high voltage to 12 volts for the low voltage system, and also reverses its step up to charge the battery while braking. So with the regenerative braking, it kind of sends it backwards and it sends it back into the battery. So in this case, this vehicle has a high voltage battery assembly. They said 360 volts on the previous screen. Then it's got a high voltage joint box, and then this is the electronic ECU assembly, and then a battery management system as well, and then a voltage control unit and load detection circuit. And that'll change it between the 360 volts and the 12 volts, and everything just kind of melds together in this assembly, and then it transmits the voltages where they need to go. Regenerative braking system, like I said, transfers energy from braking to charge the battery. Some vehicles will also do it on coast, just coasting, not even tapping the brakes. Uses the electric motor as a brake. We still do have hydraulic brakes that it would use, but just to do that initial slowdown, it's going to use your electric motor, which in turn becomes a generator. So a motor is going forwards, and then the generator is when we're going backwards. So in this case, we have a reduction gear in the motor, an electric power control unit, which would then, which is what we just talked about on the previous slide, and then it's going to go back and it's going to charge that high voltage battery a little bit. I think if you're probably going down a decent incline for a while, if you're in the mountains or something like that, you probably get a decent charge out of it. But just coming to a stop in residential traffic, probably not. I don't think it's going to make a huge difference, but I guess any difference helps. The electric motor is going to run on high AC voltage. It's usually a three-phase AC. Could be 500 volts or more. It's used to drive the wheels. Like I said, there could be multiple in the vehicle as well, just depending on how it's set up. Used to charge the battery during regenerative braking, and most are three-phase AC motors. Now, if you take a look at this one, on the manufacturers that have traditionally had internal combustion engines in their vehicles, or have the option to have an internal combustion engine in the same vehicle they also make an EV out of, you see how this just kind of looks like a traditional internal combustion engine in a package with a transaxle, a couple motor mounts and such, and CV axles there. They would just take the internal combustion engine and all the stuff that goes along with that, and then they would just plop in the electric motor, and it saves parts complexity by doing it that way. So some manufacturers do that. Some manufacturers just purpose build an EV from the ground up, and then you don't have to worry about things like that. But it's just some interesting engineering that I've seen out there. Oh, yeah, like a Hyundai Kona, for example, could be gas, could be hybrid, could be EV. So all they got to do is just basically swap out the powertrain, and then you get whatever type of vehicle it is. Part of the motor is going to be the resolver assembly, and this is basically like a position sensor for the motor. So it's going to be it's going to have this sensor here. This is a sensor ring, and it's going to have a rotor in there that's pressed onto a shaft, and then the rotor goes inside the stator, and then it generates a voltage across, comes out, and that is going to be the resolver there. So we see we have where do we have it in there? There's the traction motor. There's the resolver. So you're positive and negative on your resolver. Multiple other resolvers there as well. And then this is the actual drive for the motor. It's going to be your U, V, and W because it's a three-phase motor. And then the resolver is kind of like a position sensor, rotational, right? Rotationally on there. The reduction gear is going to take place of basically the transmission, or works kind of as a transmission, I guess. Changes motor speed and torque, reduces rotational speed, and increases the amount of torque going out. And that is one thing that is, I don't know about necessarily unique, but it is to EVs and hybrid vehicles, anything basically running off that battery. It's pretty much instantaneous torque. So torque goes, and it's going to, by reducing the rotational speed going in or going out, it's going to increase the amount of torque to the wheels. So you can have almost instantaneous torque with an EV. And of course, the hybrid or the high voltage battery, we'll get to hybrids in a minute, but the high voltage battery must be charged. So home chargers and charging stations can be used. There are a couple different standards out there in the industry. I know a little while ago, I was reading where a lot of the traditional OEMs like Ford were going to the Tesla style charger because they have the largest network out there, of course. So everybody's kind of going to make a running change to that charging style, so that way we didn't need adapters and multiple charging station styles out there. Just let's just unify around one. Makes sense. And since they have the largest infrastructure out there, it just makes sense to just gravitate to that. Regenerative braking, like we said earlier, also can provide some charge, but like I said, it's probably going to be negligible. So a couple different ways of charging it. You can do normal charging, just like through your wall. If you have a charging station at your house, if you had an EV, it would go through normal charging through the onboard charging system, and then it just goes in that way. Quick charging basically gives you a straight shot into the battery. So we get a couple relays will close, and that'll provide just a straight shot of voltage right into the battery directly, which allows a higher rate of charge. Of course, it's higher current flow as well. And then there's the electronics ECU and the motor, and then the 12-volt battery there. And of course, like we said, it's the three phases on the motor. So here's just an example of the of a circuit on that. So high voltage junction block is going to go in there. From the charging connector goes in here, and like I said, there's going to be a couple different relays in there. When it tells it it's in quick charge mode, it'll close the relays and close the circuit and allow it basically to charge directly to the battery. Now, as far as diagnosing an EV, most of the time, most of the literature you read from OEMs is, hey, you're probably just going to use a scanner because it's got a lot of complex computers and electronics and stuff. You're usually just going to diagnose it with a scanner and just work through the flow chart the way it says. High voltages require caution working on many components, so like I said, if it's orange, you probably want to be very careful. 12-volt systems can be diagnosed like any other vehicle. So if it does have a 12-volt system, like the radio, any of those types of things, you're going to just diagnose it the way you normally would. The power seats and wipers and the lighting systems, probably 12 volts, and so on and so forth. And then also component testing, right? So since it's high voltage, you're probably going to be using a scanner, not a component tester as such. High voltages do require caution working on many components. I will show you a couple examples of guided component tests we have on that. But like I said, 12-volt systems can be diagnosed like any other vehicles. Most high voltage systems are not suitable to test with an automotive scope just because of the high voltages, right? Our scopes are rated up to 400 volts DC, but they say don't test anything over 50 volts. So you would need, specialized meter for that. We do have special, category. I don't forget what category you need to be in. But we do have stuff that's capable of over 1,000 volts DC on a meter, right? It's not going to be embedded with a scan tool, but it'll be a separate standalone meter just for that. Tons of specialized electronics tools that we have, insulated screwdrivers and wrenches and ratchets and stuff like that, just for working on electric vehicles. So there's tons of tools out there available. Like I said, we offer a ton of them as well. You're probably not going to be using a scope, guided component tester, but you will more than likely be using a scanner for a lot of this too. Now, as far as a hybrid vehicle is going to be similar to an EV, but it's going to have a internal combustion engine. I can't say gasoline engine because there are diesel engines that run hybrids as well. There's three main different types of hybrid vehicles. For most common one's going to be parallel. So it's going to have gasoline and electric motors linked to a common transmission or drivetrain assembly, I guess you could say. So there's your internal combustion engine. And then there's your generator or electric motor. And then there's your there's like a planetary gear set in there for, you call it a transmission, but it's not technically really, I guess, a transmission. It's more of a motor assembly with some planetaries in there. Series is another way. So that's a less common design. It's the electric motor actually drives the vehicle, and then the gas engine is used only to charge the battery itself. So that's a series presentation there. So this is really, I think, the only one this is on is the BMW i Series extended range. They have this motor in there. It's just a small little 2-cylinder motor you can see. And then that just ends up charging up the battery when the battery gets low, but the battery and the electric motor is what drives the vehicle. And then becoming more popular nowadays is plug-in hybrid vehicles. And it's probably very common, I would think, out there now. I haven't really looked at the car park in the last 4 or 5 years, but I would imagine there's a lot more of them out there than there ever were before. Gas and electric motors linked to a common transmission, just like you see on a regular hybrid vehicle. But generator motor are generally grouped in the transmission assembly, but it has a much larger battery with a greater range. So, the story here from say a Chrysler Town and Country plug-in hybrid, right? You can plug it in, and if you're only going around town getting groceries, dropping the kids off soccer, whatever, you're probably not going to ever have that gas engine start. Because if I'm just driving 20 miles a day or whatever, and I plug it in at night, it's always going to be topping off the battery. Gas engine is only used under high or low conditions, maybe climbing an incline, or if I need a good boost in power going up and off on-ramp or something like that. Let's go to components, and they're going to be very much similar to what we talked about with the EV, except for the first one, which is the internal combustion engine. So it does have an internal combustion engine, either gasoline or diesel, depending on the manufacturer and where they are. It's going to have, of course, the battery. In this case, on this one, I think this is like a Prius. Look how tiny that battery is compared to the one we were showing earlier, right? Because it's mostly done. It kind of goes back and forth. We have the battery cooling system, of course, generator, voltage converter, regenerative braking system once again, and of course the electric motor. That'll help drive the wheels as well. And this one actually, I think, is all-wheel drive. So in the rear, we see there's an electric motor back there, and there's an electric motor in the front too. So this one's actually all-wheel drive. Maybe it's a Highlander. The battery, once again, is going to be the same idea as the EV battery, but just smaller. Like I said, multiple small low voltage batteries linked in series results in a high DC voltage, can be 300 to 400 volts or more. nickel metal hydride, or lithium ion. And like I said, often smaller than an EV. And then last time, right as I was getting ready to present this class, I found this nice little nugget here. And this is really a good way if you want to compare the size of a battery between a hybrid, a plug-in hybrid, or a full-on EV. So this is from Ford, and this is comparing the F-150 hybrid, the Escape plug-in hybrid vehicle, and then Mustang Mach-E, which is EV only, and the extended range for that, the biggest battery. But total energy capacity on the hybrid, 1.5 kilowatt hours, 14.4 kilowatt hours on the Escape plug-in, and then 99 kilowatt hours on the Mach-E. So big difference there. Discharge power, charge power, power to energy ratio. So 23.3 watts per watt hour down to 2.8 watts per watt hour. I think that's watts. Pack weight, huge difference, 77 pounds up to a little over half a ton on the extended range Mustang Mach-E, 1,300 pounds on that, and it's kind of in the middle on the Escape. Pack volume, it definitely gives you an indicator of the size, right? 1.2 cubic feet, 3.9, and 16.2 cubic feet. Your voltages, 274 volts up to 343 volts, 300 in the middle, and then your different number of cells. So there's not a huge difference in cells there. There's what, eight cells difference there, which gives you the slight increase of the voltage. Energy capacity per cell, and then energy density there. So 7.5 kilowatt hours per 100 pounds. That's pretty good energy density, I guess. But I think that's a good visual of how big are these batteries, depending on what style of vehicle it is. The generator is used by the engine to charge the battery. It's also used to start the engine, so they'll run it in reverse. And instead of having a traditional starter on the hybrid vehicle motor, it'll run it in order to start the engine that way. Also outputs AC voltage. Like I said, it's a 3-phase AC, right? So we have that right there. So you get the hybrid computer, hybrid battery pack, inverter converter, the generator, and the motor themselves run on 3-phase AC. And in this case, this vehicle runs 201 volts DC. The AC compressor is 200 volts. So oftentimes on these vehicles, to save fuel, I guess, in the gasoline side of things, or just on an EV, you're going to run a high voltage AC compressor, high voltage water pump, etc. Then, of course, the regenerative braking system, like we mentioned earlier, transfers energy from braking to charge the battery, uses the electric motor to brake, and it runs in reverse. Hydraulic brakes are still used. The electric motor is, once again, high DC voltage, 400 volts or more, possibly, used to drive the wheels, used to charge the battery during regen, and most are a brushless type DC motor. As far as power flow, we saw a little diagram of this before, but since we have an engine and an electric motor and a battery, we have different ways we're going to be driving these wheels. So we can do full-on electric mode. It's going to pull the energy out of the battery through the electric motor right to the wheels. Hybrid mode is going to be engine and electric motor both driving the wheels, sharing the responsibility. And then in engine-only mode, we can just drive the wheels just with the engine and not use the electric motor at all. A couple different ways we can charge. So the engine can charge back through the electric motor while still driving the wheels. We can charge through the electric motor while we're in regen. That'd be a regen sign right there, charge the battery. And then the electric motor can be running the wheels while the engine is charging the battery as well. Don't know how often that would happen, but it can also charge. This would be going back through the engine and through the electric motor. That's kind of like a coast situation, I guess. And then just through regen back through the battery that way as well. There's also a couple other modes, of course. If I'm just sitting idle, not moving, we wouldn't necessarily need the engine running. We wouldn't necessarily need the electric motor. We wouldn't need the electric motor. Everything just kind of sits there in stasis. Engine braking is just going to do engine braking, and then charging through engine braking would be that way as well. All right. So that's my slides. Let's go live. Got a couple vehicles to talk about here. 4 of them. First one we're going to do is a Highlander. So it's a 2022 Highlander hybrid. And let's go into the scanner and just take a look at a few things that we can see. So on hybrid vehicles on our tools, what you're going to see is usually any hybrid related stuff is not going to be up here. Sometimes it might be, I guess, if it's a common selection. Well, you're going to see definitely the internal combustion engine and stuff like that. But if we go down here a little ways, if you have it in this category view, so we have hybrid and electric vehicle systems. So we got hybrid control, motor generator, power source, and rear motor generator. So in this case, like I said, all-wheel drive in this case, or four-wheel drive. So you got a motor generator in the front, and then you got a motor generator in the rear. We also have the hybrid control module right there. So of course we have codes, data. We got a bunch of different tests and functions we can do. So under actuator tests, it's got a lot of different on-offs. There are bidirectional controls often. So activating the different solenoids in there, the coolant pump, radiator fans, bunch of different solenoids, air shunt valves, coolant distribution valve, radiator fan, negative relay, positive relay, hybrid battery cooling fan, activate the inverter, water pump, etc. So these are just on-off, turn them on and off. We got routine tests, which are going to be things like a compression test that you can do, control the grill shutters, hybrid battery charge. That's kind of important because if the hybrid battery on a hybrid vehicle, some of them, not all of them, but on some hybrid vehicles, if the hybrid battery is discharged too low, it won't even allow you to start the vehicle. Because remember, what starts the vehicle? It's not a starter. It's the generator, right? Spins up and then starts the vehicle that way. So it just gives you a couple setup things you need. And then it says the test initiates charging from the high voltage battery charger. Hybrid battery charge activation status can be found in the data list and the light status of the battery charger. So it's a specialized charger you need. Hybrid battery charge, current value changes following the conditions. So if I hit start, you should be able to see flow into there. What are the options we got? Oh, I guess I can't graph that. Oh, there we go. So active, not active, and no data, I guess. And then I suppose there could be an actual voltage value in there as well. And then you can just stop at will as well. So that's important to do. Like I said, if the battery gets too low, I won't be able to start the vehicle. Control the motor generator, cooling oil pump, and then control the transmission oil pump as well. So those are good to have. Customization a little bit. We got body control with torque demand. And then we have some special functions in there like readiness monitors, battery status information update. So if I needed to, it's necessary to update battery status info stored in the ECU and turn the lamp off on the meter after the HVEV battery stack replacement. So once I replace the battery, I need to do this. Use this function to update battery status info temporarily since it takes too much time to update the information automatically by plug-in charging. So this kind of is a fast track to, we're going to update the battery state according to the computer. Let's see, confirm the following conditions, no code stored, and then I think I can't go too much further. It's going to error out, or it's just going to give me no communication, right? So ignition is on, check connection between scanner and vehicle, etc. So I'm just going to exit out of that because, like I said, I can't do that. Cruising range reset, grill shutter initialization. If I replace the grill shutters, I may need to do a reinitialization. Not every vehicle needs it, but this one may. Switch specs, switch grill shutter controls, ACT position learning, etc. Okay, and now special functions, and then next thing be motor generator. So come down here to motor generator, right there. So once again, codes, data, actuator tests. We got the cooling fan, routine tests. We're gonna have control the oil pump. And then system tests, we're going to have readiness and resolver learning and initialization. Remember how I talked about that resolver earlier, which is kind of like a position sensor for the motor. So if we go in there, function used to learn and initialize the correction amount for resolver variations, execute relearning for the resolver when parts are replaced, further repair manual and use this function. It's going to give you a couple conditions. You would go in, you can do either initialization or learning. I can't go any further because I'm in the simulator. I'm not hooked up to a car, but you would go in there whether you need to initialize it to start or you're relearning took it out and put it back in sort of thing. And then of course we can exit and it'll give me an error anyway. One other thing I also mentioned was guided component tests. So some manufacturers, depending on the manufacturer and how much information we have, you may see if you go into guided component test, if you have a tool with guided component test in it, you go into hybrid electronics. And then we have the high voltage cooling system pump, high voltage warning, high voltage inspection mode, safety. And then the rest of these are about, we got the cooling system pump we can test and operate, right? So we can go in there, see the signals and grounds and stuff like that. And then we can do a DC voltage test on it. And we can also do a signature test on it. So that is going to be a pulse width modulated signal. So you can see they've got square wave there. High voltage warning, inspection mode, safety gloves. It's just, this is going to be information about part numbers and stuff, auxiliary batteries, and so on and so forth. So depending on the vehicle, depending on what information we have, you may find guided component tests in there. Next one I want to do is Kia Niro. So that is a hybrid as well. Electric and hybrid systems contain high voltage batteries, so be careful. So this is a hybrid because we do have engine in there, but I'm going to go down to our hybrid electric vehicle, and we go into like battery management, for example. We got functional tests in there. It's going to a bunch of different fans in there, different relays, main relays, pre-charge relays, 12-volt relays, system ID. It's going to tell you what system software version it's running. And then system tests, got a couple different charge tests in there for state of charge calibration, isolation breakdown detection functions, inspection of insulation resistance, because they all have to be isolated from each other in the pack. And also a couple for the 12-volt batteries. Oh yeah, I was going to go in under data under there. So battery management system, and anytime you go into a battery management, you're usually going to have voltages for each cell. So we can see in there, there's 64, probably 64. Yeah, 64 different cells. Battery cell voltage deviation, it can only be a couple tenths before it's going to cause problems. Max internal resistance, cell number, so it's going to measure the cells and see who has the highest and lowest resistance. Highest and lowest voltages, because they want to be balanced. And if they're not balanced, then you have an issue within. So max cell voltage, min cell voltage, and then what cell caused that max and min cell voltage is going to be in here too. Yeah, max cell voltage number and minimum cell voltage number. So if you had to go in there and take apart the battery, which you can, there's actually businesses out there now that's what they do. They rebuild battery packs for hybrids and EVs, and they've got a nice little business going on that. So there are businesses out there that do just that, or specialize in hybrid cars, or specialize in EV cars. So it is out there, and the information is out there. All right, so that's that one. Another one I wanted to show you is this Kona. So like I said, you could find a Kona gas, you could find a Kona hybrid, you could find a Kona electric. So in this case, we're going to look at the EV. This is a full EV. Notice how we don't have an engine up there. So this one does not have an internal combustion engine in it. But we still do have ADAS and stuff like that, audio, video, body control modules, etc. But if we go down in a motor control battery management system, and there is a system test that we added in here, which is a high voltage battery health check. So it's kind of an automated test that'll walk through with that. And test will check health of high voltage battery. And do you wish to continue? Yes. And then first thing it's going to do is battery health checks. Is going to be the state of charge of the battery system, percentage-wise, and then state of health. And of course, in this case, they're both going to be 0. So when I hit continue, it's going to fail because it's not where the percentages should be. It should be high, above 80 or 100. And then it's going to give us data on max cell voltage, minimum cell voltage, max and minimum cell voltage numbers, like we said before. Goes through that, health check complete. So it's going to tell you what the state of health of the battery is, and it's going to tell you what battery has the highest and lowest voltages on there. It's just kind of a real quick, get you through it. I can run that status test really quick on a car. State of charge calibration, state of health again on that. And then lastly, we'll have our other full electric vehicle, which would be a Tesla. Now, Teslas, since they never, ever had internal combustion engines in them, they're built purposefully from the ground up as an EV. So they do things very uniquely because they never had to abide by OBD or anything like that. So they just kind of do their own thing. Pulling codes, the codes are totally different, like the way they're set up. A lot of times just fixing the vehicle is going to be basically turning it on and off again. But if we see all these different electric vehicle things, charging port, charger, charger slave, charger masters, DC-DC inverter, drive inverter, supercharger, secondary charger, paddle monitor, all sorts of things. Battery management system. So the battery management system, there's going to be, like I said, they do things different. Reset different codes that are in there. Reset different error messages that are in there. Reset contactor stress counter. Open positive contactor stress result. All it is just a simple reset too. And it's just there's hard resets and soft resets as well. But oftentimes that is how you fix a problem on one of these things. It's almost like plugging it, unplugging it, plugging it back in again. We do a hard reset or a soft reset, and we just resets it back. Hard reset, boom, resets it, right? There are special things you need to do. You need to get into like maintenance mode and things like that, and it'll tell you how to do it before you plug into the vehicle. So like I said, they just do things differently. And we've talked about them at length on this channel, so some other vehicles you can find. Also on Tesla, when we added the vehicle communication software, we also added in guided component tests. Now, as of right now, it's just on the ABS system, but things like the ABS module, you can go in there, find out the different pinouts on that. Things like wheel speed sensors, iBoost pedal sensor. There's different things in there. DC voltage tests. You can go in, it shows you how to hook up. And then you can come down, and there's what it's going to look like. And there's where you're going to test. Should have 5 volts with ignition on. There you go. Walks you through it, how to do it. All right, so that is my kind of high level on hybrid and even EV vehicles. Hopefully you got a couple little tips and tricks in there that'll help you along your way, because if you haven't started working on them, they're probably not going away anytime soon. I mean, kind of go through the industry news, and sometimes you see, oh yeah, some manufacturers said they were all in and now they're not all in, and it's kind of in flux right now. But I would imagine hybrid for sure is going to be here for a long time, just because it has benefits of both. And plug-in hybrids for sure, it gives you definite benefits of longer range on the EV side of things and much less fuel usage. Like I said, if you're just doing 20 miles or less a day, that gasoline engine, a plug-in hybrid, might never turn on. So huge gas savings. All right, let's talk about next week. So next week, we are going to go to all new classes again. And it is going to be our OEM-specific ADAS training we've been doing this year. Next week's OEM is going to be VW and Audi. So we're going to walk through that. I was actually just working on that class today. So we got a lot to talk about in that. They're a little unique. There's a couple little features and functions that they have that other manufacturers don't seem to have decided to take on. And then also, I find unique about it is there's not a lot of differences between the years and the models. They kind of just found one thing that worked and they kind of stick with it. So that's kind of nice. So join me next week, as always, every Tuesday, 6 and 9 Eastern, snapon.com/OT if you want to join on Zoom. Otherwise, the 6 p.m. class goes live to the YouTube channel, which is youtube.com/snapon-diagnostics. If you want to scan that QR code, it'll bring you right there and subscribe you. 9 p.m. Eastern class goes live to our Facebook page as well as Zoom. So it is Snap-on Diagnostics Products and Training is what they call it now over there. If you want to see any of our other classes in this series, this is class number 114. So it goes anywhere from intro to ADAS I did way back in 2020 all the way through. All the different components and different systems and all sorts of different stuff we talk about. And they're all free. They're all roughly half-hour-ish length. So if you want to get some more free diagnostic training, feel free to go over there. Also, do we have your email address? If we don't have your email address, then you may be missing out on some valuable diagnostic information, such as technical focus articles, SureTrack blogs, quick tips, new product releases. Hey, we did just release a new product here recently. And oh, hey, by the way, this week, if you're on 25.2 software, which is the latest software revision, we have a service release that is out and available. It's going to be available throughout the week. And that should help with some usability things. I know Canada's getting Mercedes-Benz auto-auth, or not auto-auth access, secure gateway access on Mercedes-Benz due to that update and change. So lots of different things. You would get an email about it. So if we don't have your email address and you're not getting our emails, scan that QR code right there, plug in your particulars, and you'll start getting them. All right, time for questions. If you do have questions and you joined on Zoom, just use the Q&A button. If you have a question on YouTube, just feel free to use the live chat. But before we do, I also want to reiterate and mention that my buddy Keith also does free diagnostic training. His is scan tool specific. So it's on every Wednesday is on Zeus and Zeus Plus, and on Thursday is on Triton and Apollo tools. Takes you from everything from soup to nuts through setup functions, through buttonology of the tool. This button does this button does that. Walking through fast track intelligent diagnostics. And that's about an hour. And then he takes about a 5-minute break and then comes back and talks all about the scope and meter functions, which is another probably 45 minutes to an hour, depending on the tool. So well worth your time. Sit down, have the tool in front of you, walk through it as well as Keith is walking through it at the same time. Very helpful class. Keith's very knowledgeable on the tool. He's been with us since the Sun Machine days. So since the late 80s, early 90s. So he's been around for a long time. Huge well of knowledge. Definitely worth your time. All right, let's get the questions. I got one on the Zoom. Let's see what we got. Jay saying thanks. Thank you very much, as always, for attending. I appreciate that. Let's look at YouTube. Tyrell George says, from Trinidad and Tobago. Hey, nice. That's a beautiful part of the world. I know a few friends of mine who are in tribute bands, and they actually used to go down there and play for a weekend. Thousands of people out there just watching them play. It was pretty cool seeing the pictures. I never personally got to go, but seems like a beautiful, beautiful part of the world. New Level Auto says, does Snap-on have any test equipment for testing motor phase current? I don't know if we have any specialized equipment for that. I know I haven't seen any for it. Probably the best place to look would be in the catalog or the online catalog, shop.snapon.com. And I think we have a separate like EV section there, or at least you can look up for EVs. I don't think there's anything specific for phase current though. Terrell George also asked, what scan tool would you recommend to be used on hybrid and EV vehicles in the Caribbean? So, I'm not sure what our distribution is like in the Caribbean. I know through like Mexico and Latin America we have distribution, and they are Sun-branded tools. But if you can get your hands on a Snap-on or Sun-branded scan tool down there, any of the ones we provide would have the same coverage scan tool-wise, same functionality as any of our, from the lowest level tool to the top level tool, they all cover the same years, makes, models, tests, functions, data, all that stuff. So whatever one you can find, I guess, would be the one you could use, right? Because like I said, they're the same across the board as far as coverage wise. It's just they add additional features on as you move up the food chain, right? So yeah, really anything Snap-on or Sun branded down there that works on the vehicles that are in your country would be perfectly suitable. Let's see. Airkate says, what region do you work in? When I worked for Toyota, I actually didn't work for Toyota. I worked for Subaru. So in Subaru is Subaru New England. I work up in the Northeast. So good question though. Nick says, hi from England, as always. It's very late. Go to bed. Let's see. New Level Auto, Keith DeFazio. Yep, I work with Keith a bit, doing like what do I want to say? We do these big like weekend events where people come in and they get trained, and he's one of the trainers and I'm one of the trainers, and we've gotten to know each other over the years. So yeah, Keith's a good dude. Thanks for giving him a shout out too. And then of course Keith Ray and Nick Taylor, our welder guy. So yeah, a lot of Snap-on guys. So we appreciate your loyalty to us and training and learning. All right. With that, I think that's that. So I will say thank you. Thank you very much for spending a little bit of time with me. Hopefully you picked up a couple little tidbits on hybrid and EV vehicles. Hopefully you'll join me next week for VW and Audi ADAS specific stuff. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.